Introduction to graph theory. So first of all, you should know what is a graph. Graph is a collection of vertices and edges. Sometimes we call this edges as lines. So it is a collection of vertices as well as edges. We denote it by G of V comma E. So V is set of vertices and E is set of edges, or simply G or G of VE. Example, you can say this graph, it contains 4 vertices. So in this, the vertex at V is V1, V2, V3, V4. There are 4 vertices. Similarly, the edge set is denoted by E1, E2, E3, E4. Now, what is the use of graph theory? Why we need to study graph theory? Graph theory has a wide range of applications in the fields of mathematics as well as engineering. Especially in computer science, graphs are used to represent networks of communication, data organization, etc. In electrical engineering also, graphs are extensively used in designing circuit connections. So, graph theory is the study of graphs that concerns with the relations among vertices and edges. So here the number of vertices in a graph is called as order of a graph. So order is 4 here, and size, the number of edges in a graph is called as size, and this is also 4 in this graph. A graph with no edges, a graph with, for example, if we take this, a graph with no edges is called as empty graph. Graph with no edges is called as empty graph or null graph. And a graph with only one vertex is called trivial graph. So if you say, if we take the graph with only one vertex, this is called as a trivial graph. Next we have multigraph. The graph is said to be multigraph. It is having parallel edges. Parallel edges means between any two vertices. You can see here V1, V3, we have more than one edge. Between any two vertices, if we have more than one edge, then those edges are called as parallel edges. So this is an additional edge, this is an additional edge. So if I take V1 and V2 in this graph, there are two additional edges. This is additional edge. So these are called as parallel edges. So if any graph containing parallel edges, this type of parallel edges between the vertices, then we call it as multigraph. And suppose we take a loop at this vertex. This loop is starting at the vertex V2 and ending with the vertex V2 is called as self loop. So self loop is nothing but it is a loop starts and ends with the same vertex. Next we have simple graph, a graph without loops and parallel edges. Suppose we take a graph of this form. Here we observe that between the vertices A, B, C, D, E, we could not notice any parallel edges, more than one edge between any two vertices. So that's why this is a simple graph. General graph means containing both multiple edges and or loops or both of them is called as general graph. So it can contain loops or multiple edges or parallel edges, then it is considered as, or both, it can contain both loops as well as parallel edges, or it can contain only loops, or it can contain only parallel edges, then that is called as general graph. Next, to complete graph. So we consider any graph G in which n greater than or equal to 2 means number of vertices greater than or equal to 2, then that graph G is said to be complete graph if there should be an edge between any two distinct vertices. Between any pair of vertices there should exist an edge. For example, we take this graph. This is V1, V2, V3, V4. Between V1 and V2 there is an edge. Between V1 to V4 there should be an edge. Then V1 to V3. So from this vertex there should exist an edge between all the other vertices in the graph. Next we consider this vertex V2. V2 to V1, V2 to V4, V2 to V3 also should be present, so that there exists an edge from V2 to all other vertices of the graph. Similarly V3 and V4. Therefore we call this graph as complete graph. Generally we denote complete graph by Kn. So this graph we can write it as K4. Similarly this is K2 and triangle graph is K3 and so on. So that if you consider any graph with any number of vertices, so that if we establish an edge between every pair of vertices, then it becomes a complete graph. Complement of a graph. Suppose we have a graph G consisting of this many vertices and edges, then complement of a graph denoted by G bar. So complement of a graph G bar is equal to Kn minus G. That means this is a graph with 4 vertices. Let us consider a K4 graph. First we consider a K4 graph. This is K4 graph with 4 vertices. Then G bar will be, G bar contains those vertices which are not present. This is K4. The vertex, we compare this graph with Kn and we denote edges which are not present in G as compared with K4. So this edge is not present as compared to K4, and this edge is not present in G as compared to K4. So G bar is this. Consider the following graph. We define degree of a vertex. So suppose we take a vertex V1. Degree of vertex V1 is given by the number of edges incident on the vertex V1. Suppose we want to say degree of V2, that is counted as the number of edges incident on V2. So let us take V1, V2, V3, V4, V5 and V6. So in this V1, vertex V1, how many number of edges incident on this? 2. Now V2, if you consider, since it is a self loop, degree of self loop is 2. So that this is 2 and this is 2, so we write 4. And then V3, there is no edge incident on this, so degree of V3 is 0. V4 is 3, V5 is 4 and V6 is 1. Only one edge is incident on this, therefore V6 is 1. and edge any edge or any vertex containing degree 1, that is called as pendant vertex. So any vertex containing degree 1, it is called as pendant vertex. And any vertex whose degree is 0 is called as isolated vertex. Isolated vertex. In case of directed graph, suppose we have a directed graph like this, we define in degree and out degree. In degree means the number of edges towards the vertex V1. Number of edges directing towards the vertex V1 is called as in degree of that vertex. Out degree is nothing but, suppose V1, out degree is nothing but the number of edges starting from the vertex V1, or the number of vertex moving out from the vertex V1, that is called as out degree. For example, if we see V1, the number of vertex towards V1 is 1, out degree 2. For V2, towards V2 is 2, away from V2 0. V3, towards V2 0, away from V2 3. V4, okay, for V4 let me add some self loop, so that for V4 in degree, for self loop in degree is 1, out degree is 1, so that this will be 3, in degree is 3 and out degree is 1. Self loop, in self loop out degree is counted 1. Subgraph, suppose we take a graph G. It contains 5 number of vertices V1, V2, V3, V4 and V5. Then G1, the graph G1 is said to be subgraph of G. Let us take graph G1 in this form. Subgraph of G is denoted by G1 it is like a subset. Subgraph, so the vertices and edges of G1 should be part of G. Okay, you can see here these two vertices, this is V1, V2 and this is V5, V4. This is as compared to the vertex G, as compared to the graph G. So G1 contains all the vertices of G, also G1 contains all the edges. Not all the edges, but the edges of G1 are in G and the vertices of G1 are in G. Therefore, G1 is part of G. Therefore, G1 is subgraph of G. Induced subgraph. Suppose we take a graph G contains 4 vertices, then G1 is said to be induced subgraph of G if we consider the vertex induced subgraph of G induced by the vertex set V is equal to, suppose V1, V2, V3 induced by the vertex set V1, V2, V3. Then first we denote 3 vertices in the same place, V1, V2, V3. So between V1, V2, V3, what are all the edges which are there in G? So that we need to write here. So then we say that this graph G1 is induced subgraph of G induced by the vertex at V1, V2, V3.